Let us understand the problem. Suppose an integer from 1 through 1000 is chosen at random. Then we have to find the probability that the integer is a multiple of 2 or a multiple of 9. We have here three things to determine, that is number of multiples of 2, number of multiples of 9 and number of multiples of 2 and 9 combined together. So, let us first find out how many number of multiples of each of these are there. So, first let us list all the multiples of 2. Multiples of 2 we have 2, 4, 6, 8 and the last one is 1000. Then we shall write the multiples of 9. So, we have multiples of 9. So, if we list them 9, 18, then 27, then 36 and etc. we have 999, that is the last multiple less than 1000. Then we shall write the multiples of both 2 and 9 together. So, multiples of 2 and 9. So, if we list them, they look like 18. The first one will be 92, 18, then 36, then 54, etc. The last one is 990. Let there be n number of multiples of 2, m number of multiples of 9 and p number of multiples of 2 and 9 taken together. Now, we shall find out n, m and p. Observe that this is an AP, this is an arithmetic progression, the sequence of numbers is in AP. Therefore, what is the formula for the nth term? We have a plus n minus 1 into d is equal to the nth term. And in this formula, a stands for the first term. So, here a is equal to 2. D stands for the common difference, that means 4 minus 2, 6 minus 4 etc. and which is equal to 2 in this case. And nth term a n is this last term 1000. Now, we know a, d and a n. So, from this formula we can find n, that is number of multiples of 2 we can find. So, let us substitute these values in this formula. Therefore, 2 plus n minus 1 into common difference is 2 is equal to 1000. Now, observe that a 2 is common throughout. So, if I take out that 2, then I have 1 plus n minus 1 is equal to 2 into 500, because 2 into 500 is 1000. Now, I can cancel this 2 both sides. Now, we are left with 1 plus opening the brackets n minus 1 is equal to 500. Again, this 1 can be cancelled, plus 1 minus 1. Therefore, n equal to 500. So, therefore, how many multiples of 2 are there? There are 500 multiples of 2. Now, same way, let us find out the multiples of 9. So, we have the formula here. Again, the same formula holds. A plus, we are assuming m number of multiples. So, we shall write m minus 1 into d is equal to am is the mth term. And what is a in this case? The first term is 9. The common difference d is 9 again, because 18 minus 9, 27 minus 18 etc. is 9. And the last term we have is, that is the mth term, is 999. Let us put these values in this and find out what is m. So, here 9 plus m minus 1 into d is 9 is equal to 999. Now, I can see a 9 common throughout. So, I can write this as 9 times 1 plus, here m minus 1 is left. If I write this 9 outside, then this is equal to 9 into 111, because this is 999. Now we can cancel this 9 on both the sides. So cancelling 9, we are left with 1 plus m minus 1 is equal to 111. Again we can cancel 1 and therefore now we have the value for m as 111. That means from 1 through 1000 there are 111 multiples of 9. That's what we found out. So this also is done. Now let us find the multiples of 2 and 9. So here again we have, now here we have the formula to find p. We have to find p. So the number of multiples of 2 and 9. So that will be a plus p minus 1 into d is equal to ap. Now what is a? The first term here is 18. The common difference d is also 18 and the pth term is 990. Now we shall put these values in this formula. So a is 18 plus, we have to find p, so we don't know that, and d is 18 is equal to 990. Now I can see 18 common throughout. So I shall write 18 outside. 18 into 1 plus p minus 1 bracket closed is equal to 18 into 55. Now we can cancel 18. Therefore, we have 1 plus p minus 1 is equal to 55. Again cancelling 1, we get the value of p as 55. So what is this p? P equal to 55 means there are 55 integers between 1 and 1000 such that they are multiple of both 2 and 9. Now that we have found the number of multiples of 2, multiples of 9 and multiples of both 2 and 9, we can now go ahead and find the probability that the integer is a multiple of 2 or a multiple of 9. So before we find the probability, first we have to also find the number of multiples of 2 or a multiple of 9. So we have found 2 and 9, but we want 2 or a multiple of 9. The number should be either 2 or 9. We have the formula n of a union b is equal to n of a plus n of b minus n of a intersection b. Now here we want multiple of 2 or a multiple of 9. Therefore, I can write n of multiple of 2 or multiple of 9 as equal to n of multiple of 2. So, n of, I am simply writing 2, that means multiple of 2, plus n of multiple of 9. Again by n9 I mean n of the number of multiples of 9 and minus n of 2 and 9, number of multiples of 2 and 9, that is what this means. We have found the number of multiples of 2 as 500. So this is nothing but actually, if I want to write, so this is, we have found to be n plus this is m minus p, in other words. So now let us put the values for this. So n we found to be 500 plus what is m? 111. So m is 111 minus p is 55. So p is 55. Now what is this value equal to? This becomes 611 minus 55 and which is equal to 556. 556. So therefore number of multiples of 2 or multiples of 9 is 556. Now we are ready to find the probability. Therefore the probability of multiples of 2 or multiples of 9 is given by the favorable number of outcomes upon total possible outcomes. Now this 556 is supposed to be the favorable number of outcomes, and what are total possible outcomes? 1000. 1000, these are total possible outcomes. Therefore, the probability is given by 556 upon 1000, and which is equal to 0.556. Therefore, this is the required probability. Therefore, required probability is equal to 0.556, and this is our answer.